Hey guys, so today we're going to be talking about a function, what exactly is a function, and how we can represent them. So let's get started. So here we have that a function is a relationship between blank and blank. In this case, we're going to be talking about the relationship between inputs and outputs. So let's write that in there. Inputs and outputs. So now here we have this little box here, which we're going to call a function f. This function is going to be a machine where we're going to put stuff into it, which we're going to call inputs, and we're going to get stuff out, which we're going to call the output, right? So thinking of a machine, we could just think of a car wash where we input dirty cars and we output a clean car. So there's 4 different ways to actually represent a function, right? The first way we're going to talk about is going to be verbally. Verbally is just where I just give you a sentence and then you can look for the relationship between an input and an output, right? So let's just write the sentence out where we talk about the distance in miles traveled in a morning run T hours later, right? And I'm actually going to make a small adjustment to this sentence, right? I'm actually going to write this T variable, this T, in a red color. Just to emphasize on T there. So here we have a relationship between an input and an output, right? So the input here, where you're inputting into your morning run, is obviously going to be the time, right? So that's what you're measuring, how much distance you're traveling. So here we have a time relationship to a distance traveled in miles. So now we're going to translate, we're going to transition from a verbal representation to a numerical representation, which numerical representations are normally done in tables, right? So here we're going to write out a table of this little story that we have of this morning run. So let's say your morning run took 4 hours. So we're going to look when you hadn't started running yet, to 1 hour later, 2 hours later, 3 hours later, and 4 hours later. Let's say before you started running, you had traveled 0 distance, because that makes sense. You haven't started running yet. 1 hour later, you have traveled 5 miles, 10 miles, 15 miles, and at the end of the run, 4 hours later, you have traveled a total of 20 miles, right? So that is our data that we have, our representation of our function in a numerical notation, numerical representation of it, right? So now we're going to transfer this data from numerical all the way to visual, right? So when we think about visual, which is my favorite way to represent a function, is through a graph. Alright, so here we're going to turn this data into a graph by simply plotting these points, which we're going to call our relationship between our time and the distance traveled. So here we have time and distance traveled in terms of time, right? So let's label our, here we have 1 hour later, 2 hours later, 3 hours later, and 4 hours later. We have 5 miles, 10 miles, 15 miles, 20 miles, right? So then we're going to just draw this into some points. Here we're going to have, first you have 0, 0, because you haven't started running anything. Then after 1 hour you have 5 miles, after 2 hours you have 10 miles, 3 hours you have 15 miles, and 4 hours you have 20 miles, right? So we have our relationship there, right, which we clearly have a positive relationship between the time that you run and the distance that you travel, which means that the more you run, the more time you're running, the more time that you input, it's going to be the more distance that you can output, right? So just draw a nice little line connecting these dots. It's kind of fun. And now I'm actually going to talk about something that you may have or may not have heard before, which we're going to call the vertical line test. Alright, so the vertical line test is something that lets you know when you have a visual representation of a function if that representation, that graph that you have, is actually a function or not. So how it works is very simple. All you have to do is just draw vertical lines through your graph, and I'll show you how we're going to do that right now. We're just going to draw vertical lines, like vertical lines through your graph, right? And then what you have to make sure is that they only intersect once. They cannot intersect more than once, right? So we're going to see here intersects once, 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 and so forth, right? So you may think like, well, one doesn't intersect, right? When does it intersect not only once, when does it do more than once, right? So let me show you an example of a graph, not a function, of a graph that fails this test, right? So actually we edit this graph a little bit. I'm going to make a little point out of this. Now, we draw some vertical lines through it. You see, here it only intersects once, right? But now, over here in these two lines, it fails the vertical line test because it intersects more than once. You actually have two intersections, right? So this is a very good example of a visual representation of what is not a function because it fails the vertical line test, right? So now that we understand the vertical line test, we can move on to the algebraic representation of a function. And I'm actually going to remove myself from here. I'm gone. So I can explain that a little better. Maybe till we run out of space. I'm back. So algebraic representation is going to be something like what you're used to. When you think of a function, you're like, okay, give me an equation, right? So algebraic is going to be equation in that form. So we're going to think of this as f of x equal to something, right? In this case, we're going to give an example related to our story here of running, right? Which is going to be d, right? Distance in terms of time equal to 5t, right? So we're just going to say that. That's going to be our representation of how we're going to talk about a formula, an algebraic representation of a function. This is just for this example, but we can see anything. It can be something like y equal to 3x plus 1, s of t equal to like 7t plus 5, or like f of x equal to x squared plus 1. These are all representations. Let me remove myself from there so we can talk about it a little better. So x squared plus 1 is just different types of ways that we can talk about functions. Alright? So those are the 4 ways that we can actually relate to these functions. And now we're going to move to something else. I'm back. So here we have all functions need a blank and blank variable. So what goes in there is going to be an independent and a dependent variable, right? So what this talks about is that all your functions are going to have an independent and dependent variable, which relates to what we were just speaking earlier about an input and an output, right? So whenever we have the independent variable that is related to the function's input, right, which in many cases it is also its x values. So we're going to put that in parentheses because it's not always x values, but most of the time it's going to be x values. Then the dependent variable is related to a function's output, and it's going to be its y values, right? So in this case, we're going to relate inputs to the independent variable and outputs to the dependent variable. All right? So now let's look at an example of this, how we can put all this together, right? So here we have a little story here. According to Mike's doctor, he will be growing 2 inches every year. He is currently 5 feet tall. And now we're going to numerically show his height over the next 4 years. So we need a numerical representation of this little story that I told you here, right? So we're going to make our own little story and kind of put it into its proper representation. So when we talk about numerical, that translates into a table. Let's not forget that, right? Numerical is a table. that we have. So let's draw a little table here. Please excuse me, not the best artist. I don't have the best handwriting. I just like numbers. So here we have his the independent variable, his input is going to be the time, right? So we have the time, and then his dependent variable is going to be his height, right? In terms of time. But we have a little issue here, right? For the time, for the independent variable, it's okay because you want to know how tall he currently is to his change over the next 4 years, right? But now here we have that every year, right, he's going to grow 2 inches per year, right? But then we're told that he's 5 feet tall. Okay? So we tell ourselves, okay, when we go with height, we need to pick a unit, right? So is it going to be in inches or is it going to be in feet? So here we have obviously one measurement in feet, and the next measurements are going to increase in terms of inches. So we should change this 5 feet to inches. So we ask ourselves, how many inches in a foot? That's 12, right? So we have 12 inches per feet. So we have 5 feet, right, times 12, right? So or just 5 times 12 to be able to get 60 inches. So we know that 5 feet is equal to 60 inches. So our initial height is going to be equal to 60 inches. All right? So then we know that every year he's going to be growing 2 inches. So after 1 year, he's going to be 62 inches, then 64 inches, 66 inches, and then 68 inches. All right? So this is how we're going to numerically show his height over the next 4 years. So after 4 years, starting from today, he's going to be 68 inches tall. This is how Mike is going to measure his height. All right? So now we're going to move on to the next example, where we're going to talk about expressing this f of x in a numerical and a visual form, right? So first of all, which way is this given to us? This is given to us in an f of x equals a function kind of thing, right? So this is actually an algebraic representation, right? So we need to remember that. So now they want us to first go from algebraic to numeric and then turn it into visual. So we're going to go through 3 of them right here, right? So once again, we're going to talk about numeric. So we're going to have our little table here. Let's try a little extra, you'll see why. And I like really suck at drawing tables. But here we have x, right? And then we're going to pick some classic values. Whenever we need to turn something from numeric to visual, whatever we do is we like to stay with a standard set of numbers, which I always like to pick -2, -1, 0, 1, and 2, which is a little bit of the negative values, a little bit of the positive values. All right. So now here we're going to have the f of x equal to x squared plus 1. Right? So now we're going to input some values in here. So we're going to input our x's, right? Our x's here into our f. So we're going to replace every x here with our values for x that we're given. In this case, it's -2. So it's going to be -2 squared plus 1. And that is equal to 4 plus 1, or 5. Then it's going to be -1 squared plus 1 equal to 1 plus 1, which is 2. Then we're going to be given 0 squared plus 1, which is going to be equal to 0 plus 1 equal to 1. Then we're going to be given 1 squared plus 1 equal to 1 plus 1 equal to 2. And last, we have 2 squared plus 1 equal to 4 plus 1 equal to 5. So now we have the numeric representation of our graph or a function, I apologize, and it's going to be -2 with a 5, -1 with a 2, 0, 1, 1, 2, and 2, 5. So now that we have our table, now we have our numbers, we can go from there to visual. So visual, like I said, means a graph, right? While numeric means a table. And now we're just going to draw a little graph, right? Our x values, which is our inputs, or our independent variable, always goes in the horizontal x-axis, while our dependent variable goes in the vertical line, which is the y-axis. We're going to plot those. So -2, -1, 0, 1, and 2. And then we draw our y values, which are 1, 2, 3, 4, and 5. We kind of look at what we need. We don't need to draw everything. And now we're going to plot them. Right? So we're going to have the first point is -2 with 5. Right? So -2, 5. So -2, and we go all the way up to 5. So then the next point is going to be -1 and 2, -1 and 2. And the third point is going to be 0 and 1. So 0, 1, always go to the x first and then y. So then 1 and 2, so 1 here, 2 up. And last will be 2 and 5, so 2 to the right, 5 up. Over here. Now we connect those dots. And then we have our visual representation of this function. And if you have any questions that this is the function or not, or you may have drawn it correctly or incorrectly, you can always do what we talked about, which is called the vertical line test that we talked about earlier, right? So we pass vertical lines through this graph. They only touch once. So we have successfully had an algebraic representation of a function f of x equal to x squared plus 1. This right here is algebraic, as we said. Then we have turned it into a numerical representation, and then we have gone from there and made it a visual representation. Alright? So we have used every type of our representations that we have learned. Alright? Now thank you guys, and I'll see you next time.